Hello class! Today we are going to continue our discussion of logic and we are going to look at conditional statements. So of course our first question is, what is a conditional statement? And this is a logical statement with a hypothesis, which we will call P, and a conclusion, which we will call Q, usually written in if-then form. So if P, then Q. Okay, so we got an example of that right here. If you pass your test, then I will take you out to eat. All right. This is a conditional statement because on the condition that you pass the test, then I will take you out to eat. So real quickly, let's take a look at this. Of our sentence, what is the hypothesis? Right? The hypothesis is you pass the test. Right? The word if is not a part of the hypothesis, only the part after that. So you pass the test. Okay? The conclusion does not include the word then. It is the then part, but it does not include the word then. It is just, I will take you out to eat. Okay? That is the conclusion. So, if you pass the test, then I will take you out to eat. This is a conditional statement. Is this a true conditional statement? Well, let's take a look. Actually, there are some possibilities here. And so we're going to look at this. This is called a truth table. Okay, so let's see here. We have some different things could happen, right? First, you really could pass your test, so our hypothesis is true, and I really do take you out to eat, so my conclusion is true. So was I telling the truth? Yeah, you did your part, I did my part, I told the truth, we went out to eat. True statement. All right, I'm not really going to take you out to eat, don't think I will. So that brings us to our next possibility. You really do pass your test, so we have a true hypothesis, but then I don't really take you out to eat because I can't afford to take all of you out to eat. There's a lot of you. All right? And so now, was I telling the truth when I said, if you pass the test, then I'll take you out to eat? No, I was liar, liar, pants on fire, right? Didn't do it. Why did I not do that? There we go. Didn't do it. So this is a false statement. I lied to you. Sorry. Okay, but there are other possibilities. What if you don't pass the test? Okay, so you don't pass the test, so the hypothesis is false, and I don't take you out to eat. So the conclusion is false. Was I telling the truth when I said if you did pass the test, then I would take you out to eat? Well, yeah, as far as you know, right? As far as you know, if you had passed the test, I would have taken you out to eat. So it seems like I was telling the truth. You didn't pass the test, though, so sorry we didn't go out to eat. Oh, well. But there is another possibility. What if you don't pass the test, so a false statement on the hypothesis, but I still take you out to eat, so I have a true statement on the conclusion. If my pen will work. There we go. Now, was I telling the truth? Well, actually, yes. I didn't say anything about what would happen if you failed the test, did I? I just said that if you passed, I'd take you out to eat. Maybe I just would have taken you somewhere better if you had passed. You failed, and I felt like being generous, and so we got out to eat anyways. You know? But I would have gone somewhere better if you had passed, so still. But still, I'm telling the truth, right? Because I didn't say I wouldn't take you out to eat if you failed. I just said I would take you out to eat if you passed. So if you'll notice, the only way that this comes out as a false statement is this one right here. This is the only way we get a false statement. If the hypothesis is true and the conclusion is false. If the hypothesis is false, you cannot say one way or the other about whether it's true. So we're going to say it's true. Okay? If the hypothesis is true and the conclusion is true, well, obviously that's true. But if the hypothesis is true and the conclusion is false, that is the only way to come up with a false statement. Okay? Now, we need to look at something else before we get into some more of this. Oh, wait, I did forget to tell you. Notice this symbols right here. We have P arrow Q. The way this is read, this means P implies Q, or if P, then Q. As I've told you before, geometry is very much a language of symbols. This is the symbol that means if P, then Q. Okay? So there you go. Now, what we're going to look at here, this is negation. The negation of a statement is the opposite of the original statement. So in words, we might say not P. With symbol, we have this little squiggle right here. So this little squiggle there, that means not. So this is not P. Okay? We're going to do a couple of examples here just to look at this. So here we have our P's, and here we have not P. Okay? So first, the lights are on. We want not that. We want the opposite of the lights being on. Well, that would very simply be the lights are off, right? So that is the negation of the lights being on. What about the next sentence? Goku is hungry. What is the opposite of being hungry? Well, it's not being full. It's just simply being not hungry. So Goku is not hungry. That is the negation of Goku is hungry. What about the last one? The cat is black. What is the negation of saying the cat is black? It is not saying that the cat is white. I know white is the opposite of black, but that's not what we're looking at here. The opposite of being black is just being not black. All right? Could be gray, could be blue, could be green. I don't care as long as it is not black. Okay? So the negation is just simply saying not that. Now, on the first one, why could I say the lights are off instead of just saying the lights are not on? Because you only have two choices, right? Either it's off or it's on. That's it. If it's not one thing, it must, by definition, be the other thing. Okay? With the other two, we're saying it's not that. Okay? You have some options. Either Goku is full, he's stuffed, he's okay, he's not really hungry. You know, you got some options. Not black. Could be white, could be brown, could be gray, could be spotted. I don't know. I just know it's not black. Okay? That's the negation. Okay? It's not really so much the opposite. That's what the definition is, but it really is just not that. All right. So let's take a look at this. This is the converse. What we do with the converse is you take your conditional statement, your if P then Q, and you switch the order. So we switch the hypothesis and conclusion. Instead of saying if P then Q, we're going to say if Q then P. So here I have a conditional statement. All right. First off, what is the hypothesis? Okay, so our statement is if you have toured the U.S. Capitol, then you have been to Washington, D.C., right? The hypothesis, remember, that is the if part. So that would be this right here. You have toured the U.S. Capitol. That's the hypothesis. The conclusion is the then part. You have been to Washington, D.C., right there. Now, really quickly, is this a true statement or a false statement? Well, let's see. If you have toured the U.S. Capitol building, where is the U.S. Capitol? Well, it's in Washington, D.C. Is it possible to tour the Capitol building without going to Washington, D.C.? No, that's not possible. You have to go to Washington, D.C. in order to get in the Capitol building, right? So this is a true statement. No, true statement. So now let's take a look at the converse, okay? So the converse says instead of if P then Q, what we're looking at is if Q then P. So what we're going to do, we're going to take our hypothesis, our conclusion, there we go, you have been to Washington, D.C., and we're going to put that in the front. If you have been to Washington, D.C., then the conclusion is you have toured the U.S. Capitol. We're taking our hypothesis and our conclusion, and we are switching the order here. Now, is this a true statement? So we need the hypothesis to be true. Is you have been to Washington, D.C. I've been to Washington, D.C. Then you have toured the U.S. Capitol. I actually have never been inside the Capitol building. I've seen it, but I've never been inside. So is this a true statement? Our hypothesis is true. I have been to Washington, D.C., but the conclusion is not true. I have never been inside the U.S. Capitol building. So this is a false statement because the hypothesis is true, but the conclusion is false. So the entire thing is going to be false. All right? So the original statement is true, right? The conditional is true, but the converse is false. The other option we have here, we have the inverse. What we do here is we negate the hypothesis and negate the conclusion. So if not this, then not that. Not P, then not Q. So we're going to take our same statement here, our same conditional statement. If you have toured the U.S. Capitol, then you have been to Washington, D.C. Okay? What we want not P, then not Q. So we're going to take these, we're going to stay in the same order, but instead of saying you have toured the Capitol, we're going to say you have not toured the Capitol. And instead of saying you have been to Washington, D.C., we're going to say you have not been to Washington, D.C. All right? So notice they stay in the same order. We're just saying not this, not that. Okay, so is this a true statement? Well, let's see here. I have not toured the U.S. Capitol, so that's true. Got a true hypothesis. I have not been in the U.S. Capitol. Then I have been to Washington, D.C., so I have a false conclusion. I have a true hypothesis, a false conclusion, and so this is a false statement. Remember, it is false if the hypothesis is true and the conclusion is false. And that's what we have here, because I have not been to the Capitol. Why is it doing that? Okay. I have not been to the Capitol, but I have been to D.C. So let's take a look at the next one. This is the contrapositive. That's a nice big word for you. What this does is it negates the hypothesis and the conclusion, just like we did in the inverse, but then we switch them like we did in the converse. So it is the inverse of the converse. Okay? So what we're going to do, we have our same statement. Instead of saying you have toured the U.S. Capitol, we're going to say you have not toured the U.S. Capitol, and we're going to move it to the back. Instead of saying you have been to Washington, D.C., we're going to say you have not been to Washington, D.C., and we're going to move that to the front. So the contrapositive says, if you have not been to Washington, D.C., then you have not toured the U.S. Capitol. Is this a true statement? Well, let's see. Let's see here. I have been to Washington, D.C., so we need this to be true. Is it possible to never go to Washington, D.C., and so that part's true, but still go inside the Capitol building? No, you have to go to Washington, D.C. in order to get to the Capitol building, right? So it is not possible for this to be, for the conclusion to be false and the hypothesis to be true. So this is a true statement. This is true because in order to get to the Capitol building, you have to go to Washington, D.C. If you've never been to D.C., you could not possibly have gotten inside the Capitol building. So this is true. So here, the conditional was true, and the contrapositive is true. All right? And that actually is how we go. If you'll notice, the conditional is true, the contrapositive is true, the converse and inverse were both false. And it's not always going to work like this, but what will always happen is that the conditional and the contrapositive will always match. And the converse and the inverse will always match. It won't always end up like this, it might end up like this. You could have a false conditional and a false contrapositive. That could happen with a true inverse and converse. But what will happen is that these will always match. Okay? Now, is it possible to have a conditional that is true and the converse also be true? Is it possible for these two to match? Yes, actually it is. For example, what about this? If a shape is a triangle, then it has three sides. There's my conditional statement, right? And that's true. If it's a triangle, then it has three sides. But what if I switch the order? Boom. If a shape has three sides, then it is a triangle. Is that still true? Yeah, that's still true. And so now our converse and our inverse are also true. And so now all of these are true, and this gets a special name. This is called the biconditional. This is when a conditional statement and its converse are both true. And this is going to be definitions. Okay? All of your definitions will be biconditional statements. And the symbols for that will have P, and then we have arrow going both ways. So this is P if and only if Q, because it works if P then Q, and we can turn it around and go if Q then P. They both work, and so this is biconditional. The way we would write this with words would be a shape has three sides if and only if it is a triangle. All right, so you see our hypothesis and our conclusion, and we just stick if and only if in between. Notice there's no then in this sentence, okay? So this is called biconditional if it comes out true all the way. Everything is true. So real quick, just to refresh this, conditional statement has a hypothesis and inclusion, and it's usually an if-then. If P, then Q. All right. Only way this can be a false statement is if the hypothesis is true, you did pass your test, but I did not take you out to eat. The conclusion is false. All right. The negation is just not that. Okay. And if you have more than one option, you can't just say instead of being black, it's white. You just have to say it's not whatever it was, not that. Okay. Converse, we're going to switch the inverse, we're going to switch the hypothesis and conclusion. They just change places. And that would be if Q, then P. Inverse, everything stays in the same order. We just put not this and not that. You put not in both of them. They both get negated. Don't just negate one of them. You got to negate them both. All right. Contrapositive, you switch the order and you negate them. Switch the order and negate them. Conditional and contrapositive will always match. Inverse and converse will always match, but they don't always match like that. If you do have it where it's true all the way through, then this is biconditional, and we say if and only if. And this is used for definitions. All right? So, hopefully you found that useful, and I'll see you in the next video.